Hi students, in previous lecture we learned what is modulus amplitude form and the properties of modulus amplitude form. So what is a modulus amplitude form? If a complex number z is equals to x plus iy, which is also be represented as z equals to r times of cos theta plus I sin theta, which is the modulus amplitude form, which is also be called as a polar form of a complex number. Polar form, that means representing as a point form of r comma theta, polar form of complex number. Okay, polar form of complex number. Okay, now where r is nothing but the modulus of the complex number, which is nothing but modulus of z, which is equals to square root of x square plus y square, and theta is the amplitude or argument of the complex number. Okay, theta is the amplitude which is given by tan inverse of y by x. Okay, just go through the previous lectures how to find out the modulus of a complex number and how to find out the argument or amplitude of a complex number if the given complex number is in different quadrants. Just watch the video. Now here the question is given that z equals to minus root 3 plus I, asking us express this in the form of modulus amplitude form. That means z equals to r times of cos theta plus I sin theta. Okay, here compare with z equals to x plus I y. Then if we compare, what we'll get over here, x is equals to minus root 3 and y equals to simply we are getting it is as a 1. Then what is the modulus? R equals to square root of x square, that means minus root 3 whole square. Okay, minus root 3 whole square plus 1 square, which is equals to square root of root 3 whole square means 3 plus 1, which is equals to square root of 4. That means here the modulus is 2. Okay, r equals to 2. Okay, r equals to 2. Now find out the argument. So here the complex number z is equals to minus root 3 plus iy. So that, sorry, minus root 3 plus I. Okay, so that means if we consider the organ diagram, okay, if we consider the organ diagram, the real part is negative, so that means it is minus root 3 and the imaginary part is positive. Let's consider this is the point. That means here the complex number, given complex number is in the second quadrant. Given complex number is in the second quadrant. Now find how to find out the argument which is in the second quadrant. So the argument can be founded. Let I am considering over here. First consider the alpha, then the argument is theta. Okay, in the second quadrant the argument is nothing but pi minus alpha. Is it clear? Just watch the video regarding which is on the argument of a complex number. Okay, then you will get the idea how to find out the argument of a complex number if it is in the second quadrant. Then I can find it is as alpha equals to tan inverse of modulus of imaginary part, that means y by x, imaginary is 1 by minus root 3, so which is equals to tan inverse of 1 by root 3. So what it is equals to tan inverse of 1 by root 3 means the angle is 30 degrees, then we can write it as pi by 6. Okay, then it is pi by 6. Then what is the argument now? Argument of z, which is nothing but theta. Okay, argument of z, nothing but theta, amplitude of z theta, which is equals to, in the second quadrant we can write this is as pi minus alpha, which is equals to pi. So what it is, pi minus alpha, pi by 6, that means we will get it as a 5 pi by 6, theta equals to 5 pi by 6. So what is the modulus amplitude form of a complex number z is equals to x plus iy? Then the modulus amplitude form can be written as z is equals to r times of cos theta plus iota sin theta. And here we obtained, for the given complex number, z is equals to minus root 3 plus I. That means, and we can write in the modulus amplitude form as r is obtained as 2 into cos theta. Amplitude is as 5 pi by 6 plus I times of sine 5 pi by 6. Okay, this is the way of finding the modulus amplitude form of any given complex number. Okay, another question. The question is, simplify minus 2i into 3 plus I into 2 plus 4i into 1 plus I and obtain the modulus of the complex number. He has given the complex number as what it is, minus 2i, 3 plus I, 2 plus 4i and 1 plus I. This is the complex number he has given and asking us to find the modulus of this complex number. Okay, just recall the properties of modulus of a complex number. We know that z equals to x plus iy. If z is equals to x plus iy, then the modulus of z is written as square root of x square plus y square. Okay, square root of x square plus y square. And we have the properties in the modulus of a complex number. If z1 into z2 into z3 and so on zn, okay, the product of all these modulus can be written as product of individual modulus, complex numbers modulus. So z1 mod z3 and so on mod zn. Okay, so now we are having, this is the question. Okay, we can write it as, so minus 2i can be written as 0 minus 2i into 3 plus I into 2 plus 4i into 1 plus I. Okay, now asking for the modulus of product of these four complex numbers. Then we can write from the property, we can write it as mod of 0 minus 2i into mod of 3 plus I into mod of 2 plus 4i into mod of 1 plus I. Okay, now this is the way. Okay, product of the individual modulus. Okay, then what is modulus of 0 minus 2i? X minus iy. It is again square root of x square plus y square. 0 square plus minus 2 whole square, which is the first one. And what is 3 plus I? Square root of 3 square plus 1 square. Okay, then 4 plus 2i, square root of 2 square plus 4 square. Then 1 plus I, square root of 1 square plus 1 square. Okay, then if we find out what we'll get, which is equals to square root of 4, that means I can write as 2 itself, and the next one is square root of 10, and the next one is 16 plus 4, square root of 20, and the next one square root 2, and which can be simplified as 2 into square root 10 into, and square root 20 can be written as square root 2 into square root 10 into square root 2. Okay, finally we will get it as, so what it is, root 10 into root 10 as 10, 2 into 10, and root 2 into root 2 as 2. then the required solution is 40. Okay, so this is the way of applying the properties of the modulus of a complex number. And the next question, given that z1 equals to minus 1 and z2 equals to I, then asking us to find the argument of z1 by z2. Okay, so argument of z1 by z2. So the argument properties, we can write this is as argument of z1 minus argument of z2, arg z1 minus arg z2. So this is the required solution we need to find out. Okay, keep it aside. Now what is the condition he has given? Z1 equals to minus 1. Okay, that means we need to find out the argument of z1. Okay, so this has to be expressed in the form of, okay, in the form of r times of cos theta plus I sin theta. Okay, r times of cos theta plus I sin theta. Here z1 equals to minus 1 plus 0 into I. Okay, then what we'll get? R equals to square root of minus 1 square plus 0 square. Simply is nothing but R is 1 itself. Okay, now, and what is theta? Theta equals to, okay, theta equals to tan inverse of imaginary 0 by real. What it is? 1. So simply nothing but tan inverse of 0. So that means here theta equals to 0. Okay, theta equals to 0. But the complex number minus 1 plus 0 I, minus 1 plus 0 I. So that means minus 1 plus 0 I. That is in the second, what is on the real axis? Minus. Okay, then we can write it as theta equals to, what it is? Pi. Okay, theta equals to pi minus alpha if we consider second quadrant, and pi minus, so this is alpha, this is alpha. Okay, pi minus 0, then we will get it as a pi. Then the argument is on the, that means real axis, it is only the real axis. Then we can write z equals to minus 1 as in the form of z equals to cos, r is 1, cos pi plus I times of sin pi. Okay, then what is the argument of z1 now? Argument of z1 equals to theta, theta equals to pi. Okay, then what is given? z2 equals to I. Okay, z2 equals to I. So from this one, for the z2, okay, for the z2, the r is equals to 1 only. But what is theta? Theta is nothing but, okay, positive only, positive axis only, positive y only. So 0 plus I. Then we can write it as theta equals to, or alpha equals to, in the first quadrant we can write as tan inverse of 1 by 0 infinity, that is equals to pi by 2. So theta equals to pi by 2. So we can write it as arg of z2. That means the z2 can be written as r cos theta, r is 1, cos pi by 2, which is equals to 0. Okay, cos pi by 2 plus I times of sin pi by 2. Okay, then the argument of z2 is equals to pi by 2. Argument of z2 equals to pi by 2. And what is asking? Argument of z1 by z2. Okay, we can write it as arg of z1 minus arg of z2. Whereas arg of z1, which is pi, and arg of z2 is pi by 2. Pi minus pi by 2, we will get the resultant as pi by 2. Okay. Now the question is, if z2 by z1, where z1 not equals to 0, okay, is an imaginary. He has given that z2 by z1 is an imaginary number, then find the value of modulus of 2z1 plus z2 by modulus of 2z1 minus z2. So that means what is he's asking us to find 2 times of z1 plus z2 by, he has given the 2 times of z1 minus z2 modulus. Okay, but he has given the condition z2 by z1. So now this condition has to be used in this one. How to use this? Simply take z1 as a common from the numerator, then we can write it as z2 by z1. Similarly, z1 as common in the denominator, we can write as 2 minus z2 by z1 modulus. Okay, so z1 and z1 will cancel out. We can write it as 2 plus z2 by z1 by 2 minus z2 by z1. But the condition, what he has given about the condition, z2 by z1 is an imaginary number. Okay, is an imaginary number. Let I am considering from the given condition, let I am assuming z2 by z1 is equals to some I. Okay, some I imaginary iota times of some y. This is I am considering z2 by z1 is an imaginary number. Then we can write it as 2 plus iy by 2 minus iy. Okay, modulus. And we have the properties from the modulus. Modulus of z1 by z2 can be written as mod z1 by mod z2. So which is equals to mod of 2 plus iy by modulus of 2 minus iy. Then what is the modulus of z square root of x square plus y square? That means 2 square plus the imaginary part square by again square root of 2 square plus the imaginary part square. Simply we will get the resultant as 1. Okay, for the given solution, mod of 2z1 plus z2 by 2z1 minus z2, the resultant as 1. Next question is, if square root of 3 plus I whole power 100 equals to 2 power 99 times of a plus b, then asking what is the resultant of a square plus b square. Show that. Okay, is asking to show that a square plus b square equals to 4. Okay, he has given that the complex number root 3 plus I whole power 100. Okay, root 3 plus I whole power 100. Then another complex number he has given RHS a plus ib, but he is asking us to get a square plus b square. How to get this a square plus b square? If we take a modulus here, then we will get square root of a square plus b square. If it is a modulus, square root of a square plus, if we square, then this will be cancelled out and we will get a square plus b square. That means simply he is asking us to apply the modulus to this given equation. So I am considering root 3 plus I whole power 100 equals to 2 power 99 times of a plus ib. Now apply the modulus both sides. Okay, now take the modulus both sides. So if we take the modulus, now what it is in the form of, then we had seen that in the properties of a modulus of a complex number, modulus of z power n can be written as mod z whole power n. Okay, modulus of z power n can be written as mod z whole power n. Now use this property, apply here, then we can write this as square root of 3 plus I modulus of square root of 3 plus I whole power 100, which is equals to, we can write as 2 power 99. So z1 into z2 mod 2 power 99 into modulus of a plus ib. Now which is equals to modulus of 3 plus I. What is the modulus of 3 plus I? Square root of 3 square plus 1 square whole power 100 equals to 2 power 99 into modulus of a plus ib is nothing but a square plus b square. Okay, so now which is can be written as, so square root of 3 whole square means 3 plus 1 4, square root of 4 which is nothing but 2 power 100 equals to 2 power 99 into square root of a square plus b square. Okay, that implies if we cancel out over here we will get only 2 only. Okay, over here we will get 2 only. Then what we will get, I am again simplifying it. I am writing it as 2 power 99 into 2. 2 power 100 can be written as 2 power 99 into 2. So I am writing again 2 power 99 into square root of a square plus b square. So from this one we can write it as square root of a square plus b square equals to 2. But what is asking us to show a square plus b square? That means now square on the both sides we will get it as a square plus b square equals to 4. Now this is the way of applying the properties of the modulus. The question is, if 1 minus I into 2 minus I into 3 minus I and so on n minus I equals to x minus iy, he has given that, which is equals to x minus iy, then prove that 2 into 5 into 10 into and so on 1 plus n square equals to x square plus y square. It is clearly that how to obtain the x square plus y square? If x plus iy is a complex number, then its modulus we obtain it is a square root of x square plus y square. Okay, so that means for the given condition simply apply the modulus. What is given? 1 minus I into 2 minus I into 3 minus I and so on n minus I equals to x minus iy. To obtain the x square plus y square, just apply the modulus both sides. Now apply the modulus, take the modulus, then what will get? Z1 into Z2 into Z3 into Zn all modulus can be written as modulus of Z1 into modulus of Z2 into modulus of Z3 into modulus of Zn equals to modulus of x minus iy. So then apply the modulus, what it is? Square root of 1 square plus 1 square for the first one and square root of 2 square plus 1 square second one, square root of 3 square plus 1 square and so on. Finally we can write this as square root of n square plus 1 square equals to square root of x square plus y square. But what we need to prove? 2 into 5 into 10, that means here we get as square root of 2 into square root of 5 into square root of 10 and so on square root of 1 plus n square equals to square root of x square plus y square. But we need to obtain only x square plus y square, just simply squaring on the both sides. If we square on the both sides, then what we'll get over here? Simply it is 2 into 5 into 10 into 1 plus n square equals to square root of, simply it is x square plus y square. The required condition is proved. Okay. Another type of problems in complex numbers is finding the locus of the given complex number. Okay, let me find out the solution for this one. How to find the locus of the given complex number? He has given that modulus of z minus 3 plus I, okay, modulus of z minus 3 plus I equals to 4 and asking us to find the locus. Let z is equals to x plus iy. Consider z is equals to x plus iy. If we substitute over here, what we'll get? X plus iy minus 3 plus I modulus equals to 4. Okay, then what it is? Separate the real and imaginary parts. We will get it as x minus 3. If we take I as a common, y plus 1 modulus, okay, which is equals to 4. Okay, so we obtain here it is as what it is. Modulus of z can be written as square root of the real part square plus imaginary part of the complex number square. So that means here we can write this is as square root of x minus 3 whole square plus imaginary part is y plus 1 whole square equals to 4. Okay, now simply squaring on the both sides, what will get? X minus 3 whole square plus y plus 1 whole square equals to 16. Now simplify this. What you will get over here? X square minus 6x plus 9 plus y square plus 2y plus 1 equals to 16. And finally the required resultant we obtain it is as x square plus y square minus 6x plus 2y 10 minus 16, which is nothing but minus 6 equals to 0. Minus 6 equals to 0. Now which is like a what it is? X square plus y square plus 2gx plus 2fy plus c equals to 0, which is the circle equation. Now the locus of, so x square given complex number z minus modulus of z minus 3 plus I equals to 4. If the condition is given, then the locus of the z is a circle. Okay, locus of z is a circle. Now another question from the how to find out the locus of a given complex number. He has given that z is equals to x plus iy. If z is equals to x plus iy, locus of z, what is the locus of z satisfying the equation modulus of z square equals to 4 times of, okay, modulus of z square equals to 4 times of real part of z plus 2. Okay, now substitute z is equals to x plus iy in this condition. What you will get? X plus iy whole square equals to 4 times of the real part of x plus iy plus 2. Okay, then modulus of x plus iy whole square can be written as what is modulus of x plus iy? Square root of x square plus y square whole square, which is equals to 4 times of real part of, if we write it as real, that means x plus 2 as a real part and the imaginary part is I plus y. Then we obtain the condition as x square plus y square equals to 4 times of real part of this condition. What is x plus 2? Simply it is x plus 2. Okay, 4 times of x plus 2. Then if we further simplify this, what we will get? X square plus y square minus 4x minus 8 equals to 0. Okay, then what is the locus over here? This is the locus of the given complex number z. Okay, and which is again in the form of what it is? X square plus y square plus 2gx plus 2fy plus c equals to 0. That means here having it is a locus of x comma y point as a circle. It is again in the form of a circle having the center as what is the center? Minus g comma minus f, and f is 0 over here. Why? Because y coefficient is not present and x is 2g equals to minus 4, g is equals to minus 2. The center of the circle is 2 comma 0 and the radius is square root of g square plus f square minus c. which is equals to, we will get it as a 4 2 square plus 0 minus of minus 8 plus 8 square root of 12 is the radius. Okay, so this is the way of finding the locus of given complex numbers. Just use the formulas whatever we have, substitute and go with the procedure. So again another question based on finding the locus of a given complex number. So what is given? Z is equals to x plus iy. This is the point here is given, and Z represents a point P in orgone plane. Okay, Z represents a point P in orgone plane, and he has given the condition modulus of Z minus a by Z plus a equals to 1. Okay, and the a not equals to 0, asking us to find the location. Okay, right, locus. Okay, he has given that z modulus of z1 by z2, the property modulus of z1 by z2 can be written as mod z1 by mod z2. Okay, mod z1 by mod z2. From this one we can write it as mod of z minus a equals to mod of z plus a. Okay, now substitute z is equals to x plus iy minus a modulus equals to modulus of x plus iy plus a. Okay, so now separate the real and imaginary parts. X minus a plus iy modulus equals to x plus a plus iy modulus. Okay, now we are having some real part plus imaginary part. Then the modulus of x plus iy can be written as square root of real part square. What is x minus a whole square plus imaginary part square y square. And from the RHS again, square root of real part, that means x plus a whole square plus the imaginary part is y square. Now squaring on the both sides, we will get it as x minus a whole square plus y square equals to x plus a whole square plus y square. Okay, so from the two sides y square will be cancelled out, and which can be expressed as x square minus 2ax plus a square, and RHS can be written as x square plus 2ax plus a square. That means here the x square from the LHS RHS, a square from the LHS RHS can be cancelled out, and we can write this is as taking into the RHS, we can write 4ax equals to 0. That implies x is equals to 0 is the locus. Okay, x is equals to 0. So what is the x is equals to 0 means? Okay, x value is 0. So if we consider the orgone plane, okay, if we consider the any Cartesian system x and y, so now this is x axis and which is y axis. So x is 0, now 0, this is the 0 0, x is 0 on y axis, x is 0 on y axis. So that means the locus of given point is nothing but y axis, that or x is equals to 0 is the locus of the given point. So this is the way of finding. Just again recall all the problems, then try to solve few more problems based on these concepts. Thank you.